right, well, let's go ahead and get started. Hello, thank you for attending. I happen to be not only the presenter, but my own moderator, so that works out pretty well. I appreciate everybody attending this session. So we are going to be looking at security by design, building resilience into industrial control systems. My name is Paul Veeneman. I am actually a recovering IT guy. I was in enterprise infrastructure globally, working both globally, nationally, and regionally for organizations on the IT side. And about 8, 9 years ago, got into freight rail. And then that led me into supporting critical infrastructure in manufacturing, as well as oil and gas, water, wastewater, and bulk electric. I hold some positions within various organizations. You see across the top below my name there. So the Minnesota chapters of ISA, ISSA, as well as InfraGard, and then also the North American lead for the OT security professionals group. So got a lot to get through here. So I am just going to get into the slides. So the agenda for today is we'll go over some program basics. If you happen to take in Ronaldo's previous presentation, just ahead of mine, we'll cover some of those items. So it'll be a little bit of repeat, but that's always good for consistency. Then we'll take a look at a real world scenario of 4 facilities, plan operation, and how we were able to use cost effective monitoring to be able to augment some additional visibility and notification alerting. And then we'll talk about automated target defense and how that relates to the proliferation and the growth of 5G ultra wide, soon to be 6G, and then eventually 7G, and communications as a source of comms to and from remote offices to a central facility. And we'll take a look at reducing the value of performance and of OSINT tools for threat adversaries. So here's a across the top. So obviously we have the asset management, always key. As Ronaldo said in the last presentation, specifically, you cannot protect what you don't know. So at the cornerstone of any cybersecurity or security program or risk management program, we always want to make sure that we have our assets in line. We want to be able to identify scope, gather asset inventory. We want to take a look at asset classifications. We want to be mindful of what the life cycle management is, and also the documentation reporting. As you can see in the cyclical process to the right there, we have a where we get into process operations, visibility, risk management, mitigation, process vulnerability tracking, and then also process operations and reliability. One of our colleagues within the industry, also the founder of OT Base, Ralph Langner, always makes a point of saying, and he is very correct, without relevant data from the OT asset management, security configurations and conclusions that are drawn are nebulous and arbitrary. And those are very important words for anyone who's building out a cybersecurity or security program to ensure process safety, productivity, and reliability. So as we take a look at what the threats are against those assets, we can look to certain criteria or standards that will help us, give us guidance to be able to do that. Obviously, everybody knows about ISA 62443. There's also the ISA TR 840009. And ensuring that we are integrating cybersecurity or security within our safety lifecycle management. Why do we take a look at risk, or what are the risks of not doing a risk assessment? We could be under-prescribing or over-prescribing, and then we need to be able to find an effective balance. You can see as we go through those various steps, reviewing tolerable risk criteria, system architecture, asset groups, being able to group and review our assets and our asset inventory, and then evaluate hazards, safeguards, and risks to those assets. And you can see along the right side, we're navigating through the risk levels. At the bottom end, we have no risk at all, which is not possible. There's always some sort of residual risk, whatever that may be, for the scope and operation of a particular facility or business or what have you. There's also at the top of that negligence, which is where we choose to not accept any risk whatsoever to the organization. And then in between, we've got these various levels going from minimum to maximum risk. And then we have to determine for the business what is going to be their acceptance level. And then everything below that is acceptable and a risk that the organization is willing to tolerate. The goal is to reduce the impact of consequences to processes and operations within our production environments. Again, always looking to maintain safety and productivity. We also want to reduce, if possible, the asset value to mission essential functions. And what does that mean? Is that we try to work through or work into our operations resilience. So that may be redundancy of systems, redundancy of communication. It could be generators, battery backup. There's a wide variety of things that we can do to not have the single dependence on a single point of failure within our business process. So again, it's important to understand that asset value and its and how it's related to the mission essential functions, how we want to be able to reduce that asset value, which sometimes sounds counterintuitive, reducing an asset's value, but it's the asset value to the process. And if we have more than one asset able to complete a process, then we can shift a load and improve our reliability and our uptime. When we're taking a look at risk, and this is available via Allianz Commercial, this is the 2025 barometer for business risks. What causes business disruptions to organizations and what do they fear most? And you can see across, let's go back. And you can see across these 4 or 5 that all of these in one manner or another could affect our processes within the organization or within our production environments. So whether it's obviously first and foremost, and what a lot of the conversation has been here is mitigating cyber incidences, cybercrime, IT networks, service disruptions, ransomware, bleeding over and affecting, let's say, Windows-based systems such as engineering workstations or SCADA servers or local historian loss of productivity. We can certainly have natural catastrophes. There are probably more losses to natural catastrophes than in some of the more sophisticated attacks that have taken place over the last 20 years. Fire and explosion, machinery breakdown. So that's where, again, as we were seeing on the previous slide, reducing an asset's value to mission essential function. So if we know that we've got outdated equipment, that equipment is no longer available within our supply chain, then perhaps we're stockpiling parts or replacements, things that we can take care of long term and ensure that the 10 to 20-year-old equipment that has value to our business process can remain up and running as best as possible. And then supplier failure, right? So it could be a failure to get parts or the inability to get materials and resources that we need in order to maintain our operations and productivity. So supply chain disruptions with global effects occur approximately every 1.4 years, and the trend is rising. So if you happen to have got the link there at the bottom, if you happen to have a chance, I would recommend taking a look at this particular document on the Allianz site. There's a plethora of information. This is just the top screen on one of the sections and in the pages. The other thing that we want to do, and this is part of the continuous improvement, we want to be able to monitor both proactively and reactively what's going on in our environment. We'll delve into that a little bit more specifically in the next slides. But proactive threat prevention objectives, the visibility into the production environments, alerts and notifications, being able to notify appropriate personnel so we can remain left of boom or above the incident, maybe getting ahead of the game if we see behaviors or anomalies that we're not expecting. This also where you baseline your assets so you know what isn't normal, so you're able to gather that information. And then also when there is an incident, and then we have our incident response, the ability to take the appropriate measures, handling best practices and procedures to be able to mitigate the impact or the consequences of an event should that take place. So above the incident, you can see there, we want to reduce the probability or the compromise. And then below that, we want to reduce the severity or the impact and the consequences. And we have a lot of capabilities that we can put to use, whether it is reactive or proactive. Again, these are probably all very high level. And if you've seen any of my presentations in the past, we cover those as well as at just general program creation or program development for security and then also risk mitigation in operations. So talking about monitoring and detection. So, and I think it's come up in a few discussions throughout the day, is that there's always these challenges in manufacturing. And I run into them as well with clients, and they can be small, they can be medium-sized organizations. You could even have large-scale multinational, multi-global operations where a lot of the plant autonomy allows cost and resource and decision making to happen for the plan itself. So, and that brings challenges that we have to be able to navigate through as practitioners and professionals that are perhaps maybe as a third party, as a contractor or consultant, being able to work with operations, IT, OT, and engineering. And those, in a lot of cases, can oftentimes still be siloed. That can be rigid. Maybe it can be a little bit more fluid. It's hard to say. But there's certainly navigation to be done in bringing those parties together. What we're able to do for a particular client that had 4 facilities, at a primary facility, and then they had 3 remote facilities, and we also put a data collector. What this allowed them to do is cost effectively augment what they were already running. So much like organizations that may be, they may have Clarity, Dragos, Nozomi, or Armis. This can augment some of that additional information. So, and this is cost effective, again, actionable items that you could put into practice today. We were using, or we deployed Zeek, Elastic, and Kibana on cost effective hardware. And I'm probably using the term cost effective probably loosely, because as you can see there, as you take a look at the manager and worker nodes, we're talking about some M72E i3 8 gig of RAM, 256 gig SSD. So these probably may top out at about 60, 70, $80 on eBay currently. But what we wanted to do is see how low in terms of a performance hardware form factor could we get to and still get the performance that we were wanting in terms of the data collection without any impact. We're able to build out a scalable and flexible deployment. We augment, as I had said before, the existing asset inventory management, discovery, and also the monitoring. And it gave the client a second source of truth to check against the previously installed or the platforms that were already in place. So if we happen to see something that didn't quite jive, or an IP address or a MAC address or some sort of protocol communication that had come up, we're able to validate or confirm that source of truth. And then also running these off of span or mirror ports within the switched architecture allowed us to get visibility to perhaps one particular network, or maybe a series of networks if it was a span port on a tagged and trunked port. So what that looks like in a deployment, so there's a lot on the screen here, and I'll just kind of walk it through, but it's discovery of assets and protocols in the deployment. So as you can see in the upper left hand, we had the manager node or the head node, which would communicate to the worker nodes over SSH TCP, so TCP port 22. The worker nodes sat on span ports as well as the manager node, and they were able to feed that information up, and it allowed us to get more of a broader perspective or visibility to what was going on within the environment. Again, in terms of the communication, and it's going to be important when we talk about the automated target, or the automated moving target defense, is the static IP addressing, even for the wide area communications. The central facility was a public static. They had internet comms. The worker nodes would stream their information to the manager node, and then we had span ports at the various network interfaces, and we were able to capture a lot of good information. And then what that may look like, so we were able to create within the Kibana component of these of the Zeek, Elastic, and Kibana deployment, we're able to create these panels and then mold them into into a dashboard. So as you can see here, some of the red, and we're talking about baselines of communication. So we could see at the top where they happen to be some spikes. And then we did have green for the communications that we're expecting over Modbus TCP. We also had the IP address of the SCADA server at 192.168.17.11, but we were also able to see within the network that we had some of the default Microsoft MDNS communication happening at port TCP port 5353 and 5355. And then we were asking ourselves, pertinent questions as to what, is this protocol information even necessary? Can we turn these things off? Are there things that we can do to not only apply least privilege to accounts and passwords, but also to functionality and protocols within the environment? And then also on the left side, you can see where you can pick up deviations from what we'd expect to see as typical endpoint behavior. So a low number of packets, but a high throughput. Where we normally wouldn't have that inside a control process environment. So we're able to track that down and understand if there is any large data movement. So maybe the beginnings of the compromise and what could manifest itself as a data exfiltration or corporate espionage or such. It was just a streaming endpoint at the time, so we didn't have to worry about it. Then we started asking ourselves, so what about monitoring the outside edge? So getting further out and being able to see what's on the outside, peering in. Can a worker node operate out of band? Obviously it could. Could we span or set up a layer 2 mirror or a layer 2 VLAN that was just the internet connectivity and be able to set a span port against that? And to be able to monitor. And would it be meaningful to be able to collect that data? So you can see here, we would have a capture interface, the two original ones, and then we would set a span port on that outside port and be able to see what we could see on that worker node 3 or at that third physical location. And what was interesting is we were able to see on our public IP address that there was within 15 minutes, there's a fair amount of scanning. So it's 63 public IP addresses that were scanning at outside port. This is no impact to the performance of the worker node in collecting this information, even with the low cost hardware that we were using. So that's important to recognize. And in the dashboard, we're able to show where the source IP addresses were, and we were able to track that. So we started to get a pretty good visualization as to what was going on. And as the time went on, 6 hours later against that same public IP, no performance change, still working well with the worker node. And again, that cost-effective hardware, but we saw the increase. So heat maps within the dashboard, the thicker the line, and then the warmer the color got indicated that there were more consistent scans that were happening. And this started to become a trend. And it was very interesting because then after 24 hours and 7,608 scans across all public IPs, we started to get a very clear picture that there are entities out there or other source IP addresses that are being very consistent, such as out of Warsaw, Poland, in Romania. And then we were able to track back to the ASN numbers. We even tracked although they're the good guys, Palo Alto Networks has their threat dashboard that they're very proud of. Well, in order to gather that information, they have to do a fair amount of scanning of everybody. And we could see that we were under relentless attack or port scanning from Omaha and Kansas. And it turned out we tracked back that IP block, and it turned out to be Palo Alto and their Palo Alto Networks threat center that is consistently scanning. And that would probably be pretty consistent if you were to set that up in a similar fashion. You'd see those scans and those blocks show up as well. But you can see the consistency for the top scanners at the top on the left side and the amount of activity that was going on. So we started to ask ourselves as well, can we develop some sort of resilience for 5G? 5G is becoming, as I had said before, a more prolific form of communication. It's cost effective for a lot of entities, and the bandwidth is only ever increasing, and it's getting out to, in large droves, to rural America, where a lot of times some of these manufacturing plants and facilities exist for whether it's small, medium, or large enterprise, national or multinational organizations. And what we like to do is try to find a way to increase the complexity for adversaries, reduce their acquisition, interrogation of public IP addresses and scanning, and try to find a way to just make it harder for them to operate. And what we came up with was the automated moving target defense, which essentially is changing up your wide area communications where the remote edge then would be set for DHCP renewals every couple of hours. And this would be difficult to do with a carrier. So what we had to do is be able to recycle the modem on a 2-hour basis using port configuration on the UPS power supply through as APC UPS, and be able to control that through the software, the firmware on board. But to be able to simulate or be able to get that that IP address renewal and change to take place. As you can see here, is the Executive Office of the President in December 2011 said that the moving target defense enables us to create and evaluate and analyze the deploy mechanism strategies that are diverse and continually shift and change. This increases the complexity and cost for attackers. Now, obviously, somebody scanning out on the public internet, we're not entirely sure if they're a scanner or if they're a threat, but they're scanning us. And when they're just sitting there and constantly rescanning and rescanning and rescanning, that effectively is time. And that's what we always feel is against us. And the automated moving target defense allows us to flip the script, and time becomes something that we dictate. So if there is somebody out there scanning, what we want to do is move the target. So a lot of times you could take a look at Shodan today, and there's a lot of open, whether it's TCP port 502, 448 or 44818 for EIP, Modbus TCP. They're probably somewhere in the neighborhood of high 6,000s, maybe approaching 7,000 open devices. And a lot of those are sitting on that 166.254 block, which is the static DHCP reservation, essentially just a public static IP address on the Verizon 5G network. So if we're going to have challenges in appropriately configuring firewalls and open ports and conduits, and we're going to do things out of convenience, the one thing that we could do is possibly make convenience less of a factor for the threat actors. As you can see here in the diagram, we had that first IP address, which was the 101, and that was at 24. That was at 24 hours. As soon as we started rotating IP addresses on that remote edge on the cellular modem, those numbers drastically reduced. So the result was almost 94% decrease in the amount of scans that could be taken. Also on Shodan IO, Census, and Zoom I, there was zero visibility. Those IP addresses never showed up. And the most scans that we had, I think, was 511, and that was in that second rotation of 2 hours. So you can see the progression and then being able to reduce that. So we take a look at it, reducing the value and the performance of open source intelligence tools that threats and adversaries are using, just like we would. And then I think it's important to also think like a threat actor. That will allow us to prepare better in a defensible architecture. But the idea of rotating those addresses is going to be counterintuitive. If you were to go back to your network architecture group and tell them, hey, we would like to, on our wide area cellular communications, we want to change the IP addresses, or at least work with the carrier to make that happen, let's say every 2 hours, their heads would explode. Again, having been an infrastructure guy, I can relate to that. But we have to start thinking differently. We have to change paradigms, and we have to shift our views and our perspectives on what worked in the past and what was traditional. And the traditional stationary target is nothing more than time. A 2-hour DHCP renewal, again, as I had said before, rendered Shodan IO and Census and Zoom I relatively moot. And you can imagine what that would look like if tomorrow everybody started doing this, what the database, once it aged out, what the database on Shodan might look like. Instead of hundreds of thousands to millions of open IP addresses, it could be tens of thousands, maybe approaching 100,000, whatever the static center for each of those networks might be on a wide area communication. Would you do this internally on the LAN? No, there are several organizations that are working towards that. They have application endpoint software that you would load up on everything. It gets very complicated, and I'm sure there's an expense that goes along with that. But we can use DHCP on cellular edge in very specific scenarios where the remotes are through software defined networking or software wide area networking or VPN. The remotes are connecting into the host. Their IP address changes, but the center or the central core, that public IP address doesn't. So at least one of the one of the sides of the communication at the remote would be that moving public target. And to kind of bring all this together, I kind of coined and I put an asterisk there. So the IEEE, here we would want internet to be ethereal, ephemeral, and entropic, which means it becomes randomized, it changes, and it becomes nebulous. Um, as you can see in the graph here, if we had that stationary target at 24 hours, that is something that the attacker is looking for. Time is measured in persistence. But when we change that to be every couple of hours, suddenly this is what success can look like for us, but not so much the hacker. And as it says down there in bold, you're forcing the threat to start over from zero over and over and over again. And now this is something that you control. You control what time is to attacker. You control what tools they have available, and you are setting the requirements, or at least the rules of the game. And we can start playing checker, or we can start playing chess instead of checkers. I think it's also worth noting that a lot of times we hear about sophistication, the reality, and the euphemisms are that someone may come out and say that we're attacked by, a sophisticated threat actor. And there are instances over the last 20 years, Stuxnet, Indestroyer, Trisis, Triton, most recently the coordinated efforts and the use of the typhoons, various typhoons. And this may be the case. But by and large, we are making it rather easy for a hacker who they don't hack in, they log in to be able to acquire a target, interrogate a target, and then begin to look for ways to circumnavigate or thwart the layered defenses that we have in place. And when actuality, the euphemism compromised by a threat actor actually is, I'm embarrassed to say that we didn't do the basics. We didn't take away convenience, and we didn't think like a threat actor in order to be able to defend against one. That threat, or this particular saying was first coined at the beginning of the year, actually at a session that we had here by Dr. Sean Costigan. He does U.S. military and NATO policy, is currently over at the George C. Marshall Center in Germany. I want to make sure that I'm in the right question center. The chat. Here we go. Favorite so far. Thank you very much, Ms. Ferguson. I appreciate it. Thank you. So there was a lot to get through, and I apologize for the blitzkrieg that kind of took place, but I had a lot I wanted to address. If any of you were at the OT Security Conference down in Houston, we did a longer expanded version of that. Also, if anyone wants that previous presentation with the long form or this presentation, feel free to connect with me on LinkedIn. And just send me a message. Make sure you message me as well. Make the connection, message me as well, and just let me know that you'd like the Industrial Cyber Days PDF version. I always give away my decks. It forces me to come up with new stuff as opposed to just sitting on the old content. So it's forced obsolescence on my part. So thank you very much. I appreciate everyone's time. I don't know if there are any questions in the chat. Again, I'm my own moderator here, so I'm trying to make sure I didn't miss anything. I don't see the Q&A box, but if anyone does have any questions, and we do have, well, actually, you know what? 2 minutes at the top of the hour. I'm going to give you the last 2 minutes here to get on to the next session, because that's where I have to go and get our next speaker in track 2 all set up. So again, everyone, thank you very much. Really appreciate your attendance here for the Manufacturing America's Industrial Cyber Days 2025. And thank you very much for taking in my presentation as well. Everyone is busy, and everyone has other things that they could be doing. So I appreciate your time. Thank you. Thank you very much.